Hi, this is Garth Rose, the GenRocket CEO. Welcome to this executive briefing about GenRocket's synthetic data automation platform and our global deployment framework. So in a typical quality engineering process, requirements are broken down into stories and ultimately into test cases. And of course, those test cases need very specific test data to meet their requirements. Now, the industry goes typically to a production database copy that's masked. And of course, that provides realistic data, positive data with referential integrity, but there's a lot of data gaps. So you can't get new or unique data, negative edge case data, rules, not all the data based upon certain rules and conditions, and the lack of volume. So the key word here is that there's a limited data variety available in a production copy. So what does the industry do? Goes to manual methods, entry in the front end, spreadsheets, writing a script. And these are very time consuming and labor intensive. Yes, they give the data, but there's a lot of limitations. Testers run out of time. And so this is, again, not a great way to solve this. We propose a new data provisioning paradigm. We call it test data automation, where we can synthetically generate all of the positive or new unique data, all that variety of data. And our sort of tagline or saying is there are no limitations on data, and we can generate any volume, variety, or format of data. And the way to think about this, and you'll see this in this, we're going to go to a live demo shortly, that think about any test case needing data, and it maps in GenRocket terminology to a test data case. We shorten that to G case. So any test case maps to a test data case. Now we have a structured deployment model, a methodology for scaling to the large enterprise, model, design, deploy, and manage. And the first role in the modeling phase is a test data engineer. That role models different test data projects that relate back to, with full referential integrity, the application or database. Same role designs those test data cases we just talked about to meet test case requirements. And now a large distributed team of developers or testers can come into a central portal, find those test data cases and map them specifically to their test case, and then launch them in an orchestrated fashion as part of a CI/CD pipeline. And this whole environment is managed by a role called an org admin. So we just talked about self-service, distributed self-service. So just to have a picture showing this, on the left-hand side, you can see an idea of a COE, Center of Excellence model, where a small team of TDE, that's short for test data engineers, can model different test data projects, can design whatever test data cases are needed. These are made available in a portal. And then large teams of developers and testers can come into the portal, find the project, find the cases, or put in a request, and then integrate that test data case, map it to the test case in their test automation tool or developer tool. And once again, this whole environment is managed, as we said a minute ago. So we want to get into a specific example now to sort of bring this point home and show you a demo. So let's imagine a use case, a banking application. And let's say that a supervisor wants to validate bank transactions. They want to query customer transaction data. And that scenario is captured as a given when then use case. And the test cases are designed. And of course, specific data is needed in test data cases to map to those test cases. And then we can meet the objectives of that. So let's kind of walk through the example of how that request goes in, and let's give you a demo of how that works. So first of all, we're going to go to the test data request part. Upper right-hand side here, again, this is coming from the developer tester needing the data and putting a request, and they're going to come into that central portal. We call it G portal. It's G for GenRocket. That's our self-service portal. Let's go to the demo to see how that request comes into GenRocket. So now we're in the demo, and you can see that the tester can put in the request, use a given, when, then methodology, submit that, and that request goes across the system through the portal to the test data engineer. Test data engineer starts by modeling the test data project. They create the new project name, in this case, bank app, use the industry type, and they can, of course, version later on if they want to, but now they're going to create the domains using one of 14 different unique ways in GenRocket. We're showing all the examples here. One of the most popular is import from XTS. So the Test data engineer is going to use that method. XTS has a multi-step wizard-guided process, and it leverages the metadata, not the table schema, not the actual data, and it goes through a number of steps to establish the data model, referential integrity, and so forth. Then the project can be categorized. For the large enterprise, this is so helpful to be able to categorize the different projects for findability. And next step, we go to families. So large data models have a lot of tables. GenRocket has the ability to break them down into logical families. We're showing that on the screen right here. That helps a test data engineer and a tester visualize the data they're working with. Once the family is created, we can move into the design phase. The test data engineer can design with automations the data they need. Remember that test data case maps to the test case. Look how quickly a test data engineer can build all the different kinds of G cases from the G family capability. Remember, in the use case, we needed to have some positive data and some negative data. And look how quickly G cases can be built and packaged under G suites. And you can see many G cases can be added, and even G rules, test data rules, can be applied against those same test data cases. Just showing you the rules area here. We're moving on to another area. So not only rules, but also queries. Reference data can be queried from SQL, NoSQL, and spreadsheets to pull in data. And we're circling an example there from a SQL query to be able to have that reference data built right into that G case. And then they can be, for reusability, the G cases can be packaged into stories, and stories can even be packaged into epics. Very clean, structured process. Now, once the notification goes out to the tester through the portal saying, aha, we're done, we've completed the work, they're notified. So now what happens? The tester comes into the portal and says, let me go find and take a look at that data. I got my positive data set. That looks great, just matching my test case requirements. Here's my negative data set for the invalid SSNs. Great, that looks good. I've previewed the data. And here are my invalid birth dates, another negative data set. I'm ready to go. Now, in the next step, they don't necessarily have to generate the data to look at it, but just we're giving an example how in 6 seconds we can generate 30,000 rows of data in multiple formats. So you'll see on the screen, we can do XML file format, 10,000 rows, JSON, and even CSV, 10,000 rows each, all in 6 seconds. Now, we're going to move on to some test case examples. Notice on the left-hand side, we have 3 different test cases, test case 1, 2, and 3, and we're integrating the data right into the feature file. And so on the left-hand side, you'll see the test case running and calling GenRocket. On the right-hand side, you can see the UI where we have a simulated front-end application, GenRocket Bank. And what you're going to see is that we're going to be running that data and running the first test case with the positive data. There it goes into the system. You can see the data being generated. The positive data has been inserted at the front end. And now we're going to run test case number 2 and 3. And once again, you can see that data being generated in real time right into the application. And there is the negative data being inserted into the application. Really nice. Now we showed integration with a feature file, but GenRocket test data can integrate with any testing tool or framework, such as Catalan or Selenium, Cypress, or Tosca, and can be launched many different ways, such as command line or batch file or shell script, or even through a compiled or scripting language. Lots of different ways to integrate GenRocket into different testing tools and frameworks. And GenRocket supports distributed self-service by allowing testers and developers to modify and repurpose test data cases with minimal training. It's through a utility called G Questionnaire. Any test data case can be saved as a G Questionnaire template ready to be modified and repurposed. In this example, the tester or developer is repurposing a test data case designed for functional testing, but now it can be used for performance testing just by changing the loop count. What you just saw is a demonstration of how GenRocket has changed the test data paradigm. Traditionally, a static copy of manual or production data must be reserved and refreshed to ensure accurate testing. Now with GenRocket, a fresh copy of synthetic data designed for each test case is dynamically generated during each test run. This allows developers and testers to integrate multiple tests in the CI/CD pipeline. Here, we're triggering a Jenkins build that combines multiple test cases. A performance test with synthetic data repurposed by G Questionnaire has been integrated into the test run. GenRocket's integrated performance test enables a quick and effortless setup of high data volume. This blue ocean view of the Jenkins pipeline illustrates the integration of GenRocket at various test phases to create a fully automated workflow. At the beginning of the video, we introduced you to our model, design, deploy, manage, implementation methodology. And now we move on to manage, the enterprise class management capabilities for our distributed self-service platform. Let's look at how the org admin performs user management and tracks key metrics for driving continuous improvement. Using the team permissions feature, an org admin controls how users access, create, and revise test data projects. Each organization can set up any number of teams with any number of projects and users assigned to them. Team permissions provide the control needed to prevent users who may be located anywhere around the world from accessing or changing test data cases without prior authorization. The management console makes it easy for the org admin to assign users to multiple projects and set different permission levels for each project. With G-Analytics, GenRocket captures the utilization metrics needed to measure technology adoption and value outcomes. It records the number of G cases, stories, epics, and rules to track the data domains and business logic designed into various test categories. This provides a measure of test coverage. Provisioning data is the single biggest component of test cycle time. So G-Analytics tracks G case fulfillment time to measure the acceleration of data provisioning time. Recording the number of G cases executed and the volume of data generated by them measures execution frequency. And the number of G questionnaires created by developers is a measure of reusability and team productivity. These value metrics allow GenRocket customers to realize the vision of quality at speed and scale. Well, I'd like to thank you very much for watching this executive briefing about GenRocket's global deployment framework for synthetic test data automation.